No, my concept of scale time goes beyond, I think it does at any rate, beyond the Planck length, because stated later in this video, the Planck length is the smallest possible meaning unit of measure. Can't, below the Planck length is where the quantum world begins, I would say, or the division between, relativity and probability. Well, not division between relativity and probability, but the division between the quantum realm and reality. Okay, I'm babbling. I ain't gonna edit none of this, so edit none of me out. So continuing.
That space is smooth and continuous breaks down. But what happens when you go smaller? Does space break into discrete chunks? Does space even exist as we know it? Before we zoom in on space, let's
Okay.
zoom back in time to see where the idea of the Planck length even came from. In the final year of the 19th century, Max Planck.
Okay, see, I like this kind of stuff. Okay, he's going to explain how these people sitting around bored, because there wasn't no TV, no internet, no anything to keep them entertained other than ballroom music and the dome that is our sky. So, well, I'm pretty sure there were other things, but as people in general, we all get bored very quickly with the same humdrum stuff. So, and we go intrinsic. We start thinking about what if I had something else to do. Like, what's smaller than this beam? What's smaller than this speck of dust? What does a snowflake look like on the inside? You get nuts like that. Okay, here we go.
Ushered in the quantum age by thinking about what.
Oh, he's talking about Max Planck. That's the Planck length he's referring to in this to be the smallest unit of conceivable and meaningful value.
He found the long-sought mathematical description of black body or thermal radiation by requiring that the energy of light in his heat globe was not infinitely divisible. Rather, he found that it came in quanta, discrete chunks of energy that we now call photons. Planck's discovery hinges on a single number that appears in his equation, the Planck constant. It represents the chunkiness of thermal radiation. Multiply the frequency of light by this number and you get the energy of the signal.
Okay, now he's utilizing thermal radiation. And that's, you're burning a candle. And the heat, radiation, and the light, that's his light source. Something he's burning. That's all everybody's light source unless it's an arc, an arc light. But in reality, what the arc light's burning is a portion of our quanta.
Photon. Max Planck had introduced the whole quantized light thing as a mathematical trick. He expected the value of the Planck constant to be zero, which would mean that energy could be infinitely divided. But the constant remains stubbornly non-zero, even if it's very, very small. That simple fact revealed the fundamental blockiness of the subatomic world. We now see it everywhere in quantum mechanics. It is a fundamental constant of nature that defines the scale of the quantum. From the Planck constant comes the...
Okay. See, the difference between the scale of the quanta and time scale, scale time, my concept of scale time utilizes a natural number system. The system where there is nothing between 1, 2. What's between 1 and 2 is another 1 at the edge of the 1. making that point 2 points, and then 3 points, and 4 points. And continuously, the points add on. So you can't divide 1. So they can't get a 0.5 out of a natural number 1, because that is a succinct quantity. Succinct quantity. Unique and indivisible. What? Oh, open this up. Hold on. Let us continue.
The Planck length is the length you get when you combine the gravitational constant, the speed of light, and the Planck constant in just the right way to give units of length. The square root of g times h bar over c cubed, where h bar is the reduced Planck constant, the Planck constant divided by 2 pi. As you now know, the number comes out pretty small, around 10.
I noticed that 2 pi. Why does pi come up in almost every calculate in every formula concerning distance and time, when it's originally its original discovery was to find the area of a circle or a sphere. I mean the volume and area of a sphere, and 2 smooth lines. In order to, it's easy to find, how many sides there are on a square or on a triangle, because you can look at them and tell, or the length of the sides, some of the sides. But how on earth are you going to find the length of 360 degrees? And pi does that by continuously shrinking scale, by zooming in. It does that by zooming in on a point, on points between points. Zooms in. And why does just 1 pi represent the area of a square? Why does why does multiples of pi represent varying degree, increasing degrees in structure? I mean, why is there 2 pi at all for area? Oh, sir. Why? I mean, 4 pi. Pardon. Sphere. Let's see.